Hi guys, welcome back to another lecture series on artificial intelligence. This video is in continuation with a previous artificial intelligence video in which I discussed linear regression. And in that video I quoted like I'll be going ahead and implementing the codes for linear regression step by step without the libraries, without its built-in libraries like sklearn. Here I have taken this sklearn dataset only for importing the dataset. That's it. And after that, everything is being done from scratch, and that is using the NumPy array, right? And the Python. So first of all, what we do it, we'll go and go back and we'll see like what all things we had learned. We had learned hypothesis like h theta x 0, theta 0 plus theta 1 x 1 plus theta 2 x 2. Similar way it will run till theta m x m, right? So theta 0 x 0. So here x 0 is also there, but we suppose x 0 is 1, and that's why it has not been taken, right? Just keep that in mind, right? Parameters now it will be theta 0, theta 1, theta 2, theta 3, and whatever up to m, right? The cost function as usual, this was the formula. We'll implement this formula here, right? And we'll minimize this using gradient descent. And gradient descent, this was the process I explained, but formula is here, right? The formula will be like gradient descent will be using d of d theta 0, and that comes to be formula h theta xi minus yi into 1. 1 here, that means theta 0. So suppose that is 1, theta 1. In that case, we'll be using x. Here it was x0, but here it will be x1, x2, x3 in the continuation like theta 0, theta 1, theta 3, theta 4. Similarly, so this was generalized case like 0 and 1 only, but we'll be discussing for M series, right? So let's see how it is being implemented. The first step that is there is loading of the data set, right? So data set is being loaded. I have taken built-in like there is data set called Boston data set. This is a simple data set that contains features and the labels, and on which we'll be implementing our algorithm of linear regression. We'll just see how and visualize as well, right? Using matplotlib, right? Okay, so we'll load the data set using sklearn to load Boston. That will load the data set for Boston, right? So this is our data set. Now out of this data, we'll separate the features, right? So features is here, and then we level out, right? Just connect to Wi-Fi. Okay, so we have the labels. Label will be using the target, and this will be data, that is features, and target will be our level. So for target has to be converted into single column, right? So for converting into single column, what we do is np.newx, that will add another like new column to it. So it will be column vector actually, and this will be rows and column both here, right? We'll see that how it looks. So we'll first print the shape of level, right? And then features, like what are the features? Shape of features and shape of levels, you can see 506. So 506 sets of data is there, like row wise, right? And then 13 columns, which indicates all the features, and one that is last one, that will be level, right? So levels is here, and that will be printed as level. Now total samples in our data set, that is 506. You can see the data set here. Like features contains all the features like this one, this one, this one, and others, right? And then we go ahead and we have these labels. So label contains 506 different sets of different what you call uh, different people. Suppose we have 10 people, we have 506 people, and for all these people we have height, weight, degree, temperature, whatever it is, right? And out of that we want to find out that in future what will be their height, so that may be our target, right? Just taking an example, right? So these are the features. Out of these features we'll find out that what is the label in the future, or whatever like whatever model we got, right? So for that we have this data set. Feature is here, this one, and this is labels. This is what we'll use for our training. So we see that in samples of data set, we'll run that once for your convenience, right? So see guys, now it's running, right? And it's taking a bit time because I think internet may be some issue, right? Yeah, it has been executed. So see here, this is our data set, right? We have got this, we have got these features, we have got these labels, and number of columns, number of column vector and all, right? Go ahead and find out number of samples. So we'll go and find out length, right? That is a function called length that will give me how many samples are there. So actually we know, we have already seen using print that 506 samples. Then we have this mean of it. Now why do we do this mean and standard deviation? To find out our standard data set, right? Features minus mean by standard deviation gives us actual features, and that will be standard feature which we can use it for gradient descent, and that would not take much of our time, because gradient descent process is about updating our parameters, and that becomes slower because of this normal data set. That's why we standardize it. We make it certain, like in the range of something like 0 to 1, something like that. Okay, so you see here, this is our 513 506 rows and then 13 columns. So this was our standard data set, that is just I printed the shape of it, right? To save up features after h stack. What is this h stack? I'll explain that. What I had discussed is, our data set contains 506 13 columns. But what we need columns number is 14. Why? Because x0 has to be also there. And for x0, what we do is we take np dot ones, that is the rows and columns of ones, right? You can see here that makes one of the column as 1 1 1 1 1, right? You can see here 1 1 1 in each of the in this column, each rows like 506 rows, we have 1 1 1 each, right? And after that, number of features is 14. So now the number of features with us is 14. So according to that, we'll take our parameters. So parameters will be np dot zeros, n of features, like number of rows will be our n of features. Why? Because once we go ahead and do dot product of this to find out hypothesis. So to find out hypothesis, what we do is we do x np dot dot and then features comma parameter. So in that case, like whenever you multiply vectors, so number of columns should be equal to number of rows. Only then you can have multiplication, right? So that's why what we do is we implement that. We have taken it as reverse order, like transpose, you can say, right? 14 comma 1. So that will help us in finding this computation of the cost. So number of samples, we'll take this np dot dot product. You see dot product is being taken. That is the formula we had seen now, right? I'll show you that. This was the formula theta 1 x1, right, plus theta 2 x2. So that has to be continued. So that will be done by this dot product here, features comma parameters. So that will find out hypothesis. Now out of that hypothesis, we'll find out the cost, and cost hypothesis minus level, like how much the difference between this is our predicted value, suppose, with the help of those parameters which we passed. So this is parameter, this is feature, and we'll compare it with level. We have decreased it, like subtracted it, and if it comes some value, so that will be returned as cost. We'll be seeing that we have cost, we have called this cost function here, and initial cost will be something like that. You see here, initial cost is 296, means the difference between predicted and the actual is very high. Now we need to minimize this. That is our goal, using optimal parameters. Of what is optimal parameters? Like the parameters which is well fitting to our data set, in that the parameters by which we have the minimum of this np dot sum, what you call the cost. So first of the cost was very high. Now we'll apply gradient descent here. You see, first of all, we have found the cost. Now gradient descent, what it will do? Now parameters was how much? It was 0 0 0. That was started with 0. Now we have to update this parameter to some value. So what we do is we find out number of samples, we find out the cost history, np dot zeros, right? So that is just for storing our cost in each iterations, like number of times we are repeating it each time, I should have the cost actually, right? So parameters is equal to parameters minus learning rate by number of samples into np dot transpose features. Like np dot transpose, why do we do this? So that number of parameters, how many numbers of parameters are there? 14 as of now, right? We want 14. So how it has to be multiplied? Just I'll write some codes, right? How it has to be multiplied? Let's see that. 14 comma 1, this is one thing. Then we do dot product, actually dot product, right? np dot transpose, how much it will be now? It will be 14 comma 1. Then features, how many features were there? Features were 506 to 13, so it will be, now it will be 14 comma 506. Okay, got this. Now this is dot product actually, right? So this one you have seen here, this one np dot dot, it will give you how much? This will give you a vector of 506 is to comma 1. That will be the shape of it, right? So 506 comma 1. In the same way here it will be 506 comma 1. So it will be 506 comma 1. That will be the shape, and we do dot product of this. Then what will happen? This at the rate symbol is for dot product actually, right? That is shortcut. So this one, this symbol, this will give us, that will be dot product will be equal to what? Shape will be 14 comma 1, right? 14 comma 1, 14 rows and 1 column. That will be the parameters actually, right? So this parameter, to get parameter in this order, we have done this transpose, and then dot product of this you know that is actually cost only. So this formula has come from here. This formula has come from here, this one, s theta xi minus yi, you see, and then 1 by m, that is learning rate. Alpha is our learning rate, 1 by m is a number of like how many parameters, how many samples are there, and that is done dot product of xi. So that this formula comes out after this differentiation and all, which we have seen here. We have to differentiate it to find out the minimum. So after having the differentiation and all, we will get this formula, and we have applied that formula only, right? That is the formula. So it will keep on updating the parameters, and in for each updation we'll store this cost here in this compute cost, and at times after some iterations like 100 iterations, 1500 iterations, will come to a value that will be less, like very less. We'll do this with 1500 and we'll see that how much it happens. So gradient descent has been called for 1500 times. After calling for 1500 times, it returns us with optimal parameters, that is final parameters here, and then cost history. Cost history, two things. So we'll get this and we'll print this cost history last, and every parameter also, like optimal parameters for all this 14, like 2, 4, 6, 8, 14, right? 14 parameters are there, and this is the final cost, that is last. So earlier in the beginning it was 296, that was very high, but now you can see it is 11 only. So we'll do with different iterations, like we'll do, what we'll do is we have taken 0. This learning rate will increase, this learning rate also we can decrease that learning rate also, like we will do for 0.05, right? Or what happens, like we'll do for 2000 times, and we'll see it from starting. See, first step, that is data set taken up. Then we see that analyze the data set and find out the standard data set, right? And see how it looks. And then we have the cost function. Hypothesis and cost, both things is calculated here using the formula. This is updating the parameters and storing the cost. And here we have the final call to all these functions we implemented earlier, right? Gradient descent is called for 2000 times. You see it was here and it has 11 only. So this is the visualization, that this graph has come all the way, cost has been reducing, and finally it becomes stagnant, it does not reduce more. That's the limitation of linear regression, that's the limitation of this vectorized implementation. And here comes the term like that what you call machine learning with neural networks and all. because more and more times we are repeating it, it's not decreasing, right? So what we'll do is not 2000 times, we'll do it for 500 times, right? Let's see what happens. You see, it is 13, but it has reduced slowly. So we'll do for 700 times and see, right? So that's what the experiment to do. I have the code. You can go ahead and watch this video. That's all for today. Thank you very much. Do subscribe this channel. Thank you guys. Okay, bye.